The automotive industry is in a state of flux, teetering on the edge of a transformative era defined by electric vehicles and advanced automotive technologies. However, recent announcements from four major car manufacturers, General Motors, Porsche, Toyota, and Ford, suggest a potential pivot that could dramatically alter the trajectory of the electric vehicle market. These companies have unveiled groundbreaking engines that promise to revolutionize the automotive industry, casting a shadow of uncertainty over the future of electric vehicles. Mary Barra, the CEO of GM, took the stage first, revealing an innovative engine design that has the potential to redefine fuel efficiency and performance standards. Under her leadership, GM has been a strong proponent of electric vehicle technology, investing billions into the development of electric platforms like the Ultium battery system. Yet, this new engine represents a strategic diversification, blending the best aspects of traditional internal combustion engines with cutting-edge advancements in fuel technology. Barra's announcement highlighted GM's commitment to reducing carbon emissions without fully abandoning the infrastructure and technology that have supported the automotive industry for over a century. The new engine, dubbed the hyper-efficient combustion engine, utilizes a revolutionary combustion process that significantly increases fuel efficiency while drastically reducing harmful emissions. This technology integrates advanced thermal management systems and lightweight materials, ensuring that the engine delivers unparalleled performance without compromising environmental goals. Following GM's announcement, Porsche CEO Oliver Blume introduced an equally astounding engine that promises to blend the brand's legendary performance with unprecedented fuel economy. Porsche, synonymous with luxury and high-performance sports cars, has been a vocal advocate for sustainability, pioneering hybrid and electric vehicle technologies like the Taycan. However, Blume's presentation unveiled an engine that could potentially eclipse the allure of electric propulsion. Porsche's new engine, known as the Advanced Turbocharged Hybrid, really leverages hybrid technology to its fullest potential. This engine combines a small yet powerful turbocharged internal combustion engine with an electric motor, delivering instantaneous torque and power while maintaining exceptional fuel efficiency. The ATTH engine features a state-of-the-art energy recovery system that captures and reuses energy typically lost during braking and deceleration, further enhancing overall efficiency. Blume emphasized that this engine is not just about raw power, but about creating a harmonious balance between performance, efficiency, and sustainability. Toyota CEO Koji Sato then took the spotlight, unveiling an engine that aligns with the company's long-standing commitment to hybrid technology and environmental stewardship. Toyota has been a pioneer in hybrid vehicles since the introduction of the Prius, and Sato's announcement underscores the company's dedication to continuous innovation in this space. The new engine, called the Hybrid Synergy Drive Plus or HSD Plus, represents the next evolution in hybrid technology, aiming to provide a seamless driving experience with minimal environmental impact. The HSD Plus engine integrates a more efficient internal combustion engine with an enhanced electric motor, delivering improved fuel economy and lower emissions. What really sets this engine apart is its ability to operate in multiple modes, seamlessly switching between pure electric based on driving conditions. This flexibility ensures that drivers can enjoy the benefits of electric propulsion in urban environments, while still having the range and convenience of a traditional engine for long-distance travel. Sato highlighted that the HSD Plus engine embodies Toyota's philosophy of Kaizen, or continuous improvement, pushing the boundaries of what hybrid technology can achieve. The final announcement came from Ford CEO Jim Farley, who introduced an engine that promises to revolutionize the concept of power and efficiency in the automotive industry. Ford, a company with a rich history of innovation and performance, has been actively pursuing electrification with models like the Mustang Mach-E and the F-150 Lightning. However, Farley's presentation unveiled an engine that could challenge the very foundations of the EV revolution. Ford's new engine, named the EcoBoost Max, represents the pinnacle of the company's engineering prowess. This engine employs a sophisticated combination of advanced turbocharging, direct fuel injection, and variable valve timing to deliver unprecedented power and fuel efficiency. The EcoBoost Max engine also features a unique dual-mode system that allows it to operate in either a high-performance mode or an ultra-efficient mode depending on the driver's needs. Farley emphasized that this engine is designed to provide an exhilarating driving experience while also addressing the environmental concerns that have driven the push toward electrification. The announcements from these four automotive giants have sparked intense debate and speculation within the industry. While the engines unveiled by GM, Porsche, Toyota, and Ford represent significant advancements in internal combustion technology, they also raise critical questions about the future of the EV market. Are these new engines a sign that traditional automakers are hedging their bets against the full-scale adoption of electric vehicles, or do they represent a strategic effort to provide a more balanced and versatile approach to sustainable transportation? One of the key advantages of these new engines is, honestly, their ability to leverage existing infrastructure. Unlike EVs, which require extensive investments in charging networks and grid enhancements, these advanced combustion engines can be seamlessly integrated into the current refueling ecosystem. This means that consumers can, enjoy the benefits of improved fuel efficiency and reduced emissions, without the inconvenience and expense of building new infrastructure. Furthermore, these engines address some of the persistent challenges associated with EVs, such as range anxiety and charging times. While electric vehicle technology has made significant strides in recent years, there are still issues related to battery life, charging speed, and the availability of charging stations that remain barriers to widespread adoption. The new engines from GM, Porsche, Toyota, and Ford offer a compelling alternative, providing the convenience and reliability of traditional engines, but with the added benefits of modern advancements. However, the impact of these new engines on the electric vehicle market cannot be underestimated. The announcements come at a time when many countries are setting ambitious targets for phasing out internal combustion engines in favor of electric vehicles. The European Union, for instance, has proposed a ban on the sale of new petrol and diesel cars by the year 2035. While several U.S. states have introduced similar measures, the introduction of highly efficient and environmentally friendly combustion engines could complicate these efforts, potentially delaying the transition to an all-electric future. Critics argue that these new engines represent a step backward in the fight against climate change, diverting resources and attention away from the development of zero-emission vehicles. They contend that the focus should remain on advancing battery technology, expanding charging infrastructure, and promoting policies that support the rapid adoption of electric vehicles. Proponents of the new engines, on the other hand, argue that a diversified approach to sustainable transportation is essential, especially in regions where the transition to electric vehicles may be slower due to economic or logistical challenges. The strategic implications for the automakers themselves are also profound. By introducing these new engines, GM, Porsche, Toyota, and Ford are positioning themselves as leaders in both traditional and electric automotive technologies. This dual approach allows them to cater to a broader range of consumer preferences and market conditions, potentially giving them a competitive edge over companies that are solely focused on electric vehicles. Moreover, these announcements could influence the strategies of other automakers. Companies that have been heavily investing in electric vehicle technology may need to reassess their plans in light of these new developments. The pressure to innovate and stay competitive is likely to intensify, leading to further advancements in both combustion and electric technologies. The recent almost synchronized revelations from automotive titans GM, Porsche, Toyota, and Ford regarding their next-generation internal combustion engines have sent ripples through the entire industry, marking a pivotal and profoundly significant moment in the ongoing and often turbulent evolution of personal mobility. Far from being a simple iteration of existing technology, the advanced engines they have introduced, ranging from highly efficient turbocharged hybrids to engines capable of running on carbon-neutral synthetic fuels, represent a multifaceted engineering philosophy. They promise to deliver a trifecta that has long been the holy grail for automakers: truly exceptional performance that rivals pure sports cars, remarkable gains in fuel efficiency that meet stringent new global regulations, and tangible environmental benefits through drastically reduced emissions. This concerted push directly challenges the dominant and, until recently, seemingly unassailable narrative that a rapid and wholesale transition to battery electric vehicles is the only viable pathway to a sustainable transportation future. The announcements serve as a powerful reminder that the landscape of automotive innovation is far from monolithic. While billions in investment have rightly flowed into electrification, a parallel stream of intensive research and development has been quietly perfecting the century-old internal combustion engine, refining it to a degree once thought impossible. This creates a new and compelling alternative for a global consumer base that remains diverse in its needs, desires, and infrastructure realities. Consequently, the long-term impact of these advanced propulsion systems on the trajectory of the electric vehicle market remains a complex and open question, one that will be answered in the coming decade. It is unlikely that they will halt the march of electrification, but they are almost certain to reshape its pace and character. They introduce a formidable competitor that appeals to driving enthusiasts, those with range anxiety, and industries reliant on heavy-duty vehicles, where current battery technology presents significant challenges. This competition is ultimately healthy, forcing both EV and ICE developers to accelerate their own innovation cycles, benefiting the end consumer with better products and more choices. There is no doubt, however, that these new engines represent a bold and innovative step forward. They are a testament to the industry's resilience and its capacity for self-reinvention. As the automotive world continues to navigate this period of unprecedented and rapid change, the balance struck between refined traditional propulsion and revolutionary electric technologies will play a crucial and defining role in shaping the future of mobility. We are not witnessing a simple binary race, but rather the emergence of a multifaceted ecosystem where different powertrains will likely coexist, each serving the segment where it proves most effective for years to come.